show you what it's actually going to look like down here. So I got algebraic notation. Look, x is less than 2. This is algebraic notation. Just using an algebraic expression greater than or equal to. Now this one, I didn't see this because I had to scroll down. I can't scroll when I'm drawing on the screen. But we see here that x is less than or equal to 0, or x is greater than 2. So that's one. This one right here, so we know x is between 4 and -4, but notice it's a closed dot at 4, so x is less than or equal to 4, but x is greater than -4. And then this last one right here, because it includes everything, it's just all real numbers. Now here's where you're going to need some notes too. Set builder. I was right. It just says or. Okay, or I put and, but it's or. It should have been or. You're right. Nothing too funky here until we get down here. And what you need to read, make sure that E means element of. Okay? So if that E means element of, notice this one that was all real numbers. So this is all x such that x is an element of the real numbers. In other words, x is any real number. That's the only kind of weird one. And there could even be, there's other weird ones, integers that are just whole numbers and they're opposites, so none of the decimals in between, but just like 1, 2, 3, or 0, 1, 2, 3, and -1, 2, 3. So to do an element of the integers, you do that little double thing like that. You could even do an element of whole numbers, and it looks something like this. Like just that little double thing right there. There's other ones. I'll show you down below here in a second, but that's how you handle it. And the last one was that set builder notation. Or that, oh, we didn't go over interval notation. Ooh, cool. I want to go back to this. I want to draw on this. Okay, so interval notation is just a little bit different. Remember that one where I showed you where if it doesn't include a point, you have the brackets. If it does include a point, you have the square brackets, right? You have the parentheses and the square brackets here. Okay, this one would look like this. And whenever you go to infinity. So notice it's going to negative infinity. So this is the set of negative infinity to -2, or to +2, excuse me. And because it doesn't include +2, we put that bracket there. Anytime you use infinity or don't include the point, you use the parentheses, excuse me, not the bracket. Now, for this one right here, since I'm starting on the left end and I include the point, I'm going to use a square bracket and say from -2 to positive infinity. And because, again, I'm going to infinity, I use the parenthesis. This one right here looks a little different. It's going to be negative infinity to 0. And at 0, we're going to do a square bracket because 0 is included. Or it's going to be what? 2, which is not included, so we're going to use the parenthesis, to positive infinity. And because we're going to infinity, again, we use that. Now, this is how you do it. It's going to take some getting used to, but really not that bad once you get used to it. Let me go ahead and delete these, and I'm going to show you just in general what they look like. And you see it right here. And this, by the way, I should point this out. This is a notation, and it includes the union. Union means or. We have the intersection of two sets, that means and. That's why I said I should have used or, not and, earlier, because they do mean two different things. But for right now, you just say the union right there, and it means or. And keep in mind, a parenthesis indicates that the endpoint is not included in the interval. And we also do it to infinity, because infinity goes on forever, so it's like you can never reach that point. That's why we include it with that. And the square bracket means it's it includes that endpoint. Okay? So I know it's going to take some practice, guys, but just go back to this. Use this as an example. Remember, you can always find these slides online if you go to Reveal and just go look at, I should have it up on the calendar through like Sunday, but you can always back the date up and look at it, or just go to the section we're on, which is 8.1, and do launch presentation, and it'll show you these same slides. So just keep that in mind. Okay? All right. Almost done today. I know it's a big lesson, but we're getting there. These ones will go pretty quick. Tap on each button to write the domain and range of the graph. It's set builder and interval notation. So let's look at this graph right here, right? I can tell you right away that it's all real numbers for the x, right? And then for the range, it's just y is greater than or equal to -6. So if I were to look at this, so just looking at the domain is all real numbers, right? Like I said, or it'd be x is an element of the real numbers, all x such that x is an element of the real numbers, or it'd be that interval from negative infinity to an infinity. Okay? Now if you want to write down the range, let's look at that. The range is all real numbers greater than or equal to -6, which I don't know why they put it this way. Really, that's just saying y is greater than or equal to -6, but I think they figured might as well give you the word since we're essentially putting this inside of the set builder notation. That's your algebraic form right there. And then this one right here, right, we have the closed side, including the endpoint of -6, because it goes down to -6, and then it goes all the way up to positive infinity. Okay? Awesome. I think this one right here gets a little different. Okay, so let's do it ourselves now. So let's see. If I need to do this in both interval and set builder domain, or set builder. So if I'm looking at the domain and range of the function, okay, so let me write this out. I'm going to write it out myself. The domain is the x, and we see it's going to be all x such that x, it's going forever to the left and right, so an x is going to be an element of the real numbers. That's what I'm looking for. And the range is going to be all y such that y is what? It includes that right there, less than or equal to 0. That's y equals 0 right there, right? So right away, do I see anything like that? X is an element of real numbers, y is less than or equal to 0. Right here. Boom. We know it's A. Okay, now let's do it in interval notation. Well, it's going to be x. X goes from what? Negative infinity to positive infinity because it's all real numbers. And it's closed because there's no endpoint on infinity. All right, and then what's the range going to be? The range is the y, right? It's going to be, oh, it should be a square bracket, right? Okay, it worked. Just delete. So it's going to be a square bracket right here. And it's going from 0 to where? To negative infinity, right? So that's open. Do we see that anywhere? Negative infinity to infinity and 0 to negative infinity. Oh, I see what I did wrong. Does anybody see what I did wrong? I did make a mistake. Negative infinity comes first. So even though we would normally say y is less than or equal to 0, it's from negative infinity up to 0 because you always go from the negative to the positive. So yeah, and that is which one? That's this one right here. Boom. So you guys see what I did there? Boom. Hey, I don't mind making a mistake. You guys can see it. Okay. And just to show you, because I like to do that, let's delete that. Let's go. Look at that. We did it right. I know this is a long lesson. It was thick. Sorry, guys. It took a while, but hey, you'll be set up for a good weekend of homework. And for those of you that already struggled through with the homework, good for you. So let's look at this. The domain right here, right? The x. Notice the x. Our x is, I'm just going to write on this, right? Our x is less than -1, and our x is greater than or equal to 0. So let's find that. Our x is less than -1, right? It doesn't include that, and it's greater than or equal to 0. Perfect. So that should be all x such that x is less than -1 and x is greater than or equal to 0. And if it's less than -1, that should be open bracket. If it goes from 0 up to positive infinity, remember infinity always has the open bracket, right? And then let's talk about range, the y direction. Well, just looking at it, it doesn't include -1, but its y is going to be less than -1. So less than -1. And then this includes it, and that's at y equals 2, so greater than or equal to 2. which means y such that y is less than -1 and greater than or equal to 2. And it goes from negative infinity to 1, but it doesn't include 1, so that's an open bracket. And from 2 to infinity, but it includes the point 2, so it's a closed bracket there, right? Or this was a parenthesis, this is a bracket. There we go. How do we do? Boom. And that's how we roll on this. Last thing of the day. We're it. Way to stick with it. 31 minutes of math. You guys are crushing it, probably more since you've been pausing. We're going to look at this one. This one's pretty awesome. Just right off the bat, notice in the y direction, this is going forever, right? In the x direction, it has some weird things going on. But let's look. So looking at the domain, the x direction, right? We notice that right here, x is less than, it includes the point -1, and it includes the point +1, but it's less than, so we have x is less than or equal to -1, or, right, the or, x is greater than or equal to 1. So if I were to write that in set build, it would be all x such that x is less than or equal to -1, or x is greater than or equal to +1, excuse me. If I were to write that in an interval, it would be the set. If it's less than or equal to -1, it's going to be from negative infinity to -1, right? This is just the domain. So we've got domain and domain. And it would be, I don't know why I'm writing it like this, but I did, so forgive me. And 1's included, so that should be a square bracket. And it's going to be a union with, from +1, which that should be a square bracket there because it includes +1, clear to positive infinity, which will be an open bracket. So we're looking for these two domains. Now if I'm looking at range, what is my range? Notice my y is everything, right? There's no break in y. It goes from positive y down, it's all y. So if I'm doing this in set builder, this is going to be y such that y is an element of the real numbers because it includes all y. Right? And what does that look like here? That's also going to be, so this is also the range in notation form. It's going to be negative infinity to positive infinity with those, with parentheses, not brackets. So let's look. I'm looking for a domain. X is less than or equal to -1 or greater than or equal to 1. Not that one. Wait. Nope, not that one. X is less than or equal to -1 or x is greater than 1. Boom. Okay, so I'm going to have to, I think it's F right here. And we see, you can almost see it right there, but it says y such that y is an element of the real numbers. So, this is the one we want, F. What else? We need to see negative infinity to -1. For domain, negative infinity to -1, perfect. Unioned with 1 to infinity. That works. And then range should be negative infinity to infinity. All right, it's D. So D and F is what it should be. Let me cut off my drawings here. Let's look. D and F. Look at that. We got it right. Awesome. Guys, this isn't hard, but it's difficult to get your brain around it. So just keep practicing. Let me know if you have questions. With that said, peace out, and I'll see you guys on Monday. Pretty sure. Bye.